Hello guys, I think we must be live now. Let me actually just change the title of the stream because I have a new keyboard and I'm ready to show you guys. Okay, yeah. Right, am I actually able to hear myself? Are you able to hear myself? Are you able to hear the typing? I mean, that's what I want to see. That's what I want to see right now. So let's do some typing here. Right, product placement. Hello Robin, how's it going, dude? Wrong project, 65, C++. And yeah, I mean, now let me pause the music right now and actually see if we're able to hear everything well. Right, am I actually able to hear myself? Are you able to hear myself? I mean, that's what I want to see. Yeah, I mean, it sounds good enough, right? So yeah, welcome to another stream, guys, and I'm very excited today because it's the first stream I'm using this beauty of a keyboard. I'm not sure if you guys can see it very well here, but as I've posted in the chat before, ooh, this is a bit too loud. This is the Emulator RT100 keyboard. Robin, I'm good. How about you? I'm good as well, dude. So I've been actually chilling for like maybe too much now, maybe like 4 days, just not done anything for YouTube, but we're back now. We gotta get to the grind. I'm actually off from work, which means that I get some time to, you know, just spend with people and also doing things that I don't normally do when I'm working during the day. So it's been good so far, but it's going very fast. Like I still have like a couple of days, but I'm back next week. So yeah. By the way, let me get myself up. I'm not sure if I can move this too much without messing up. Looks like, I'm not sure if you guys can see very well. So it's got like a little TV where you can put any kind of like GIFs that you want. I've got some Daft Punk imagery now, but it's working well. Anyway, so let's move this back. Let's see if you guys can still see my typing. I think so, right? There you go. Nothing to reveal now. Yeah, so let's actually do some C++, shall we? Let's do some C++. And I'm gonna try and make it so my microphone can pick up both my voice, my typing as well, because I'll tell you what, guys, this keyboard feels really nice, really nice compared to my old keyboards, and it's got like the Gateron white yellow switches. That's the one, the milky ones, and it's really good. I recommend it. Coding for Ayub, I can see you guys. Welcome Ayub, welcome Brock Daniel. I got a new one not too long ago myself. Feels so good. Yeah, it does feel good, dude. So which switches do you have, Robin? Because I've been like crazy looking at the differences and stuff, and I found that the yellow Gateron switches are probably the best one for me at the moment because it sounds very sort of like creamy like. But I'm excited to hear what you guys have as well. Anyway, let's open up some C++ projects, right? So I've been disconnected from something. Okay. There you go. Just my headset. Anyway, yeah. So I actually want to continue doing some work on the emulator, and I've kind of figured yesterday that it kind of looks a little bit crap right now, to be honest. I mean, what we have here is essentially just a C++ library, static library, that exposes some functions to emulate a 6502 program, right? And there's nothing wrong with that, that's fine as it is, but I just don't like the way I've implemented each function handler here. And I find this very big switch case very ugly, so I was trying to find a better way to kind of represent this. So every time you read a byte, for example, in 6502, we got to execute a instruction function, right? First thing I thought was basically to essentially put all these function calls into a map, and we just call in. We kind of call a function from a map key, right? Which probably isn't going to be as fast as a switch case, to be honest, but it breaks up this essentially like large code that I've got here, just to say, you know, if this then that, if this and that. Like all of these bits of code are essentially the same, as you can see here. They're essentially the same. So yeah, maybe I could just do a function to kind of, sorry, a map to kind of get the function calls there. Silent Cherry Red with creamy modifications. Oh, Iquinix keyboard. Yeah, I've heard of those. I had a look at those actually, but I wasn't. I nearly bought one, to be honest, Robin. I nearly bought one by the same brand that you mentioned. Let's see if I can find Iquinix keyboard. I nearly bought this one here, dude. Literally like 3 days ago. I nearly bought this one, but I realized that the Epoch Maker is a little bit cheaper, and just, yeah, I didn't fancy spending £160 on the Epoch Maker. And also, we have this little screen here, which was definitely a plus for me. It shows like the temperature, the time and stuff. It's really good, and you can take it out. I'm not sure if you can see. So I can take this module out. But anyway, it looked like a good keyboard as well, though. I haven't watched previous streams, so tell me what's going on. Ayub, there's nothing much going on, dude. But this is basically just a place where I can talk to you guys and do some code at the same time. But right now we're doing a 6502 emulator, man. That's what we're doing right now. So let me hide this element here. There you go. No more heart emojis there. I mean, you can still see it and send it. I use MX keyboard right now. The MX, the Logitech MX, yeah, that's a good one as well, Ayub. I used to have that one actually. But yeah, let's begin doing some coding, shall we? So first thing I have to implement is this sort of like map where we can basically get all the function calls, right? So something like this here. I actually did implement some of it already. So you can see here, I've got an instruction which is basically a function type that we can use to call just to represent a function that takes in the CPU and the span there. So I'm going to put all the function calls here, right? So let's do that. So I think I can do this. I think functions in C++ kind of decay to, not decay, but they can be wrapped around the function, right? So essentially if I have A0, the A0 instruction is what? A0, there's one match. Not very good. 8A, let's try 8A. Which is TXA, right? And I'm still getting used to the delete, like the delete button on my new keyboard is not next to the backspace, which is like a major problem for me. I have to like kind of go up a little bit. I'm not sure if you can see my pinky here. Instead of being here, I have to go up to here. So I get it wrong all the time. So I do apologize for this already. Anyway. Also, is the lighting working good? So we can change the light a little bit. I mean, I can reset it, or we can do something a little bit cooler. Just blue. I mean, is it gonna work in Bluetooth mode? Download. Okay, well, it didn't seem to change the color. I think I have to wire it in, and I'm not really willing to do that. Let's exit the driver. That was the driver for the keyboard that you can see, by the way. And I'm not sponsored by Epoch Maker. I hope I was. I wish I was, but unfortunately I'm not sponsored, so I'm not gonna show that stuff too much. Yeah, so let's start doing that refactoring now, right now. So this is TXA. Oh yeah, the shift is a little bit different as well, so like I'm going back every time. Okay, so what we're going to do now is just put each of these functions into a kind of map here, right? So essentially the byte represents, let me just put it here. So the byte key represents, the byte key indicates which function we need to call to handle the specific instruction. Yeah, that keeps happening as well. I'm missing the shifts all the time, and that's a major problem if you work with Vim, if you work with like the Visual Studio mappings and stuff. A little bit annoying. And the Windows key, of course. Okay, so we've done essentially this bit here. Now let's do A5. A5 is what? Ooh, so this is store into the accumulator XX, and we don't actually have a function that does this for us, right? So we kind of need to create one, I believe. So let's take all of this chunky code in here and put it into a function. I don't know where though. So where's page up? Page up, there you go. So let's, yeah, maybe put it here somewhere. Okay, yeah. Oh no, because these are branching functions, I don't want to put in the same bit of code. Let's put it here. And I hope I don't look too serious typing, I'm just trying to focus and not miss the keys too much. But anyway, how have you guys been? Like, what have you guys been up to? I mean, I've already asked Robin that question, but Ayub, this is the first time I see you in the stream, dude, in a while. So I'd like to know how you're doing, man. If I'm not mistaken, you like doing graphic stuff, right, Ayub? So I expect to see some great graphics programs. Keep missing the control as well. There you go. So store into the accumulator something, right? So we got this from this function here, STA, so 8.5. Now I'm not entirely sure if I'm actually implementing this correctly, and this is the actual name of the function, so we're going to find out. 6502 instruction set. And again, this is like what you kind of have to just go over and over again. So we are looking at the 8.5 function, right? So 8 is here and 5 is there. So STA. So store accumulator in memory. So this is the STA function. Fine. And this is actually the STA immediate, I think. Immediate mode. And is the immediate mode, this is something that you guys probably know by now, but whenever we have an instruction that takes a literal value, right? So like a byte or a decimal, we kind of call that an immediate mode. So this is the store into the accumulator, the immediate mode. So each kind of 6502 instruction has different ways of using indirection or loading values into it. The immediate mode is probably the simplest one, which is just whatever value is there. You give into the instruction, that's the value you're gonna store. We could have a memory offset as well, but this is not the one. I know that because it's here. So, okay. Now, why did I do this? Well, I did this so I can come down here and simply say 0x85 STA immediate, and I'm hoping that this is going to compile. So essentially we've done this bit here as well. Can you guys hear the clickiness? Like, does it sound good on the microphone? Because actually on OBS I've got a bunch of filters and a bunch of noise gates to make sure that my voice is heard quite well, and I'm not entirely sure that you guys can actually hear it very well on the keyboard, but let me know if it still sounds good. I can perhaps change the filters a little bit for the audio. Sounds good. All right, thank you, Robin. So this is again a different one now. This is a different one because it's still STA, right? 8D. I can tell it's STA, but it has a different addressing mode, so AD here. So this is the absolute value, and it takes 3 instructions, right? So it takes a full 16-word or 16-bit word that indicates where in memory you're gonna kind of store that, right? So yeah, I consider this is the absolute. So STA absolute, that's what we're looking for. Ooh, no. STA immediate, BNE, right? So we're gonna do another function here. It's gonna be called optional std size t, STA absolute. Or you into HT. I hate having to keep looking at my keyboard because I don't remember where the keys are. Right, so this is the other one. We can probably put a little documentation in each function as well, right? So basically, something like, you know, this function will simulate or emulate the STA in absolute addressing mode. This will store whatever value is in the accumulator into the memory address obtained from the, I don't know, the word address in the program. Something like that, right? I mean, if we can do that for every function, it'll make it a little bit easier to understand the whole thing. Do I like this song? Not necessarily. So let me swap to a new one. I found that songs that kind of have really high frequencies all the time, like the one you've just heard, make my voice really annoying. So I'm gonna try and skip them. This is a good song, but it also smells of copyright. I'll let it play. I'll let it play. Okay. Obviously we don't have the break here. We don't have the break here. And in this case, we actually do return this value, the bytes. Something I forgot to do. Ooh. So, and if you guys keep in touch with the C++ community, if you watch all the videos by all the famous guys out there, so you may have watched the Jason Turner video recently, where he shows you the effects of essentially returning optionals in C++. And it turns out that you actually can't really do return type optimization unless you do something like you make the optional very explicitly, right? So I guess make optional will do. So for example, make optional of size t, and we put in 2 here, right? I believe this allows the C++ compiler to actually just create this object once. So it's not going to create it once here and then copy it to your function call or whatever you call the function, and then destroy the previous object. It's just going to copy it in place. So this is RTO, return value optimization. And to make a point, let me do something. Let's try something out, right? So if you go if we use the Godbolt compiler explorer, which by the way is something you should all be using if you're really interested in C++, if you care about what's going on inside the code, because this will give you the decompilation for your program, right? So let me do something. Oh, what is this? This is from the DS stream, which I definitely need to continue, by the way. But So let's include optional here. I will need to write, oh, let me put Vim in here, please. There you go. Test function, right? Say we take in a power, like the base and the power, right? So base and power. So int base and int. In fact, size t base and stud size t power. And we kind of want to raise these two things. There is a power function somewhere. I can't remember which header it is. And it only works with doubles and stuff. So it's in CMaths. Right. Anyway, so CMaths. That means I have to change it to a double here, and a double here is not a problem. Right, so what am I trying to do here? I'm trying to basically show you the difference between doing return value optimization and not doing it. And hopefully we can see that by the assembly, if it doesn't generate me something extremely difficult. Let's put it as O2 actually here. Actually, let's do something like this. So my power. Something like 2 to the 10. And we're going to return my power. Just going to convert it to... Ooh, there's no triple equals in C++. Right, is this gonna work? Okay, it does compile here. In this case, the compiler does actually not generate the constructor and the destructor for it. I mean, it doesn't not do the return value optimization. It just does it for me. I think it's better represented if I do something like a struct, right? That's what Jason does in his video, so let's see if it works. So my type. And then we can override the constructors and stuff. So my type. This Vim is not good for me. My type. And I should probably put a new line as well on these so it doesn't mess up. But I want to see what happens if I actually call in the test function here, so... And can we execute the code? Execute the code. Ooh. There you go. Oh no, what am I doing? This isn't Rust. Gosh. There you go. Invalid operands. Okay, so now I want to see which objects are called here, so hang on a second, guys. I promise you there's an explanation for this. I'm not just like randomly doing some random code here. Now, which options are available to me here? No viable conversion yet. I just want to see if it's true or not. Do I really have to open the optional documentation here in C++ just to see how to convert it to a bool? Operator has value, and that returns a boolean. Okay, yeah, so we just return my option that has a value. Okay, yeah. Point here, you can see that the object is created once and it's moved out into this one here, right? So why did I write all of this code here? It's something I actually learned the other day with Jason Turner, which is one of the YouTubers that I recommend you guys watching if you're serious about C++. I've been watching him since like 2000 and maybe 17, 16, I think. So it's really good to learn new things from him. And every week he posts some really cool, like they're called C++ weekly videos where he teaches you something new about the language. And a few weeks ago he was explaining the effects of using optional in C++. It's called return copy elision. Yeah, it's called copy elision, but this one here is return value optimization, where the object is constructed where it's returned. That's a different one though. So if you just return your type converted to an optional, you're going to get this kind of behavior here, where it doesn't really create the object in place, right? What I could do is I could just return a new object here, and this is actually the initializer list that is calling this particular constructor here. I thought so anyway, so let's try that again. There you go. So you get the same behavior here. So the object is created and moved, right? It would be nice if it was just created in this stack here. That's what I'm trying to say. Apparently, I haven't actually tested this, but according to his videos, if you create the object explicitly, optional, where you do something like this, it should just be created and kind of disappeared here, which is what we get, right? It's exactly what we get. So I guess we can pass in this. Wait, what is this? This is creating a random. Sorry, this is creating a null opt. So that's why it returns 0. Hello everyone. The Giga chat also feels like MSA. Yeah. Hello Arkonaf. It's good to see you, dude. It's good to see you, man. That's another person I haven't seen in a long time, since last week. I hope you're doing well, good. I hope you're doing really well, my dude. Yeah, so in this case we actually created a null opt. So I wonder what happens if we use the stud make optional, my type, and pass in the construct there you go. This is return value optimization. So it does matter when you use the make option or not. I think I'm watching the stream for too long, so I guess I have to disappear for another month. Yeah, so hope you do, dude. I mean, you had your maths exams, right? So I hope that went well, dude. I hope you finished it now, right? And more importantly, man, because you're watching the stream, you better have got 100% on everything. But anyway, this whole thing was just to prove a point, not to prove a point, but just to tell you guys that be careful with your optionals, especially when you're doing things that are performance based. because they can kind of call unnecessary like constructors, destructors, and move operators, right? So just do be careful. And basically, this is like one of the things that you can call out C++ for not being friendly to the user with. So in Rust, this thing would almost always never happen if you're using the right tools. Because if you wrote code like this and you run it through the static analyzer, Rust would actually not let you compile the program if there's something like marginally wrong with it, and if you're doing some operations that are unnecessary. I mean, actually, it would compile. Never mind, it does compile. But Clippy, which is the Rust clang tidy, shall we say, like that, or the static analyzer for Rust will analyze this code and be like, actually, you're doing something wrong here. You shouldn't be doing that. This error doesn't get caught with clang tidy, yeah. And I know that because I have another project, a base64 encoder, that calls optional with the exact same like stuff that I was doing before. So yeah, I mean, I guess C++ Rust wins in this case for being more friendly. But yeah, just another point, just another sort of like vent here on how C++ has a lot of features that you don't necessarily know until you actually have a lot of experience with it, which isn't ideal. Shall we agree on that? Oh, a lot of messages in the chat. Arkonaf, at somewhere like the 30th day of a crunch period, so on the edge. But this place is starting to feel like home. Yeah, dude, I'm happy that you feel that way, man. Very happy you feel that way. And this should be a safe space to anyone who just wants to talk about code and chill, right? But yeah, dude, I've been there. I mean, my 30-day crunch was basically in January to February, actually, because that's when we had a major kind of, shall we say, a major event for our software. About, I think overall like 7,000 to 8,000 people used the software within the space of like a day. So I was wondering whether it would break or it wouldn't break, and it didn't break, hopefully. And I can't really talk about what it is that we developed because I don't think that's public knowledge yet. But one day maybe you'll realize. I'll be able to talk about this. But yeah, it was like a gaming project basically. Nothing too special. It's just PR things that I'm not allowed to talk about. But yeah, it all went fine. That's what I'm trying to say. So like, things will go fine at the end of the day, right? So when that happens, Arkonaf, just make sure you take a time off, dude, and you know take some time to spend with your family, to relax, and get your head out of the computer. I'm still waiting for my full RGB keyboard. Zero plastics, only LED. Dude, this is a fully RGB keyboard. Let me actually change this. Oh, you're talking about your keyboard? Only LEDs. It's lower to have optional in the function and then return it. So it's slower to kind of create your object in certain ways, your optional object in certain ways. So for example, what we had here is, so in fact we have like my type return value, and we were essentially creating this value before here, right, or something like that. But then instead of using the proper C++ construct to build the optional, which is make optional in this case, we simply used the implicit conversion in C++, because that's something that you get in C++ types, especially with the containers, where, you know, retvar, even though it's the type my type here, and let me zoom in a little bit because I'm not sure if you guys can see everything. So my type, although it's of type my type, it does get converted to an optional of my type if you just put the literal there. But as you can see that also implies that you have a random like move construct something called, instead of using the return value optimization, which is something that C++ does for you automatically. So if you have like a trivial type that you can just create at the very sort of like return status of your function, C++ will actually create this object for you wherever this function is called in that stack. So you kind of avoid a move there. So that's basically it. That's the point of this. So it's yeah, that explains the thing I thought I see in your eyes. It's dark, strange, heavy tiredness. Yeah, dude. I mean, it's rough sometimes. Sometimes I'm working very late. Plus, you know, add YouTube to that to that mix as well, and you get someone who doesn't sleep very well. You get someone who's rarely happy about any code they see. That's me. But yeah. Rust option is enum, which is actually a union wrapper, so it's very lightweight. Yeah, so Rust option is an enum. Yeah, I don't actually use that as much, by the way. I use the result. Result is just a better error handling struct, in my opinion. But those two things are, you know, very much unions in the implementation side. Anyway, back to our actual code. I don't know what I started talking about this. It's a bit random. Sorry about that, guys, if you don't enjoy that talk. But it's just because of this line of code here. That was it. It wasn't anything like life-changing for us, unfortunately. So we need to return a stud make optional here of, what is it? Stud size t. Okay. So bit by bit, we're going to kind of, you know, change this whole like switch case into just a map, a lookup in a map. I personally enjoy these small brain banters. Nice Arconath. I do too, dude. I do too. Sometimes I feel like I talk too much, so do let me know when I'm rambling on about something that isn't really part of the conversation, I guess. So STA, this value takes 3, so that's the one we did, right? AD, yeah. So AD in this case would be the STA absolute for us. And with that, we kill this off here. This branch is dead now. Are you using Microsoft or Clang Visual VS Code LSP? I think I'm using the Microsoft at the moment, to be honest. I tried Clang. Actually, that's a good question, Swap. I tried Clang literally 3 days ago because I was looking over this project and I was actually trying to get IntelliSense to work. But as we're using modules with C++23, it doesn't really work very well. And then I went to Clang D, and that's even worse. That's actually even worse. I got way more errors coming back from the LSP than I do with the Microsoft one. So that's the reason why I use the Microsoft one right now. But to be honest, as whoever implements the support for modules first, I will be all on that. I'm just waiting for it. Clang D, yes, that's true. Yeah. But it's a good question though, because literally something I did the other day, like. So let's go for this function. So this is decrement the register, and we're actually decrementing. What are we decrementing here? We are decrementing, the Y register in the CPU. So this is going to be a little bit more freaky for us to actually do, because this decrement register function, it takes a it actually takes a register and not the program with it. But to make it friendly, yeah, I guess not. I guess we can do it. Microsoft has the best C++20 support. Yeah, it does have the C++20 support, but not the LSP though. The LSP is not Microsoft. It's not by the same. Well, it's not the same project as the Microsoft compiler. That's what I'm trying to say. That is the language server, which is actually free and open source for you to look at online. So it's called the CPP tools, I think. So yeah, I don't know why but GCC and Clang added so many C++23 features, but they still have much work to do with C++20. Yeah, that's kind of true. But although I feel like that support has been improved every month, I look on the C++20 language support page, and things do improve. It just takes time. It just takes time. I mean, how many of you guys can actually implement something like module dependency scanning for a compiler? Not many, right? So, you know, don't complain that the the support takes ages. It's a very difficult task. So I realized that instead of complaining, which I do a lot of, by the way, I should probably think about the implications of getting something done. In the case of LSPs and tools for programming languages, those tend to be very hard to develop. So yeah. Yeah, let's get back 10 years and enjoy C++23. Indeed, yeah. That's how it feels, isn't it? So 0x88, so let's do it here. So I have said this before, but do excuse my typing skills today. This is literally the first time I'm actually coding with this keyboard, so I am missing a lot of keys. Why hasn't this complained about not compiling yet? Because this shouldn't have compiled. Yeah, this is another problem that we have with the LSB, with modules. It's not actually working fine, because it's not throwing me the errors for the compilation. You can check CPP reference. They added so much more C++23 features for some reason. Yeah, I know, I do check it. You know, it's a weekly process for me at this point, so. So we need a spam of uintate, right? Wait, what? What am I doing? Should have been here. So we need a spam here of a const std uint. Ooh. And we return a null up to now. See, this function should actually be returning me. Yeah, just null opt. Null opt is fine. Now this one is the A8 one, which is the registry Y decrement function. So, yeah, it's gonna be. std uintate t. I do hate how Vim misses just this angle here, and this is the problem. I think that's how you call this. Let me see. Yeah, emulator registry Y, and that's basically what we're going to return, right? Let me just make sure this function does what it's supposed to do. Returns a 1 here. Again, I'm going to just change this because I'm kind of paranoid now. Make optional. Please spell emulator. Did I miss it somewhere? Dude, I guess there's a typo in here somewhere, right? Emulator. Please spell emulator. Are you worried about this variable here? There you go. I'll put mu for you. Not the whole thing. Hope you're happy now. The kids are crying. 0x88. Right, so now we've killed this one here. There'll be a lot of things that broke, by the way, and hopefully our tests should pick those up. So, 9.1. So, yeah. Search emulator. Okay. Oh yes, I see. Thank you, dude. Thank you, artisan. By the way, are you Antonio by any chance? I know one of those names is an Antonio. And I think last time you joined there were like 3 of you guys, so it was very confusing. So 808, is that the one? 9.1, that's the one. So STA indirect. So this is, something that should be with these two functions here, actually. So that function should actually be with those, because it's the same sort of family group, right? These are all the same family. No, I'm Travis, actually. Alright, fair enough. Sorry about that, dude. So we have STA. This is the store into the accumulator indirect version. So this is where we load a memory address with the program bytes that we get given. So we get given like a 16-byte number, which indicates the position of the memory we want to kind of store from the accumulator. And we also add Y to that. That's the position here. You can see, so there's a position and you add Y to it. This is what this function does. Yeah. Anyway, so we also have that problem here. Of not returning a proper return value optimized return value here. This is unsafe. Ooh, this is unsafe. Why did I put this comment here? Whenever I see a to-do comment in a refactoring task, I have to go for it. So why is this unsafe? Well, I am checking that, but I guess there's a memory indirection to it. Yeah, it's not as unsafe because we have 16 bytes and the CPU can access that many registers, right? So, okay, yeah, we'll be good. So anyway, why did I do all of this? So I can come down here, and 9.1 is STA, right? So 9.1. This is the one that we want, and we essentially did this one. So 8.0 is LDY, LD immediate. So this is a load into Y value now. So it loads this value into Y. And it's kind of similar to, I guess, the STA function. But in this case, it just is either it's either Y, X, or any other register, right? We don't have an LDA function, but now that I think about it, this could be an LDA. This, you know, that STA function we have is basically the same as this one. So STA immediate. So look at this one. Unless, ooh, STA 0 page. What? Wait, that function calls another function. So what does this do? The CPU memory value is just the registry A. Ah, never mind. LD is like a different thing. LD actually loads a value into the registry. So yeah, we do have LDA already. Never mind. This is a different thing. But anyway, yeah, let's change that. Okay, and now we have this kind of done for us, right? So we have, oh no we don't. So A0 is LDY. So we're gonna have to copy one of these bad boys over here and kind of paste it there. Because now what we actually have is we're loading into registry Y here, LD immediate, right? That's basically it. What else do we have? It takes the program as a second thing. Beautiful. This should also be A0, if I'm not mistaken. Yeah, A0 there. Now A2 is the same thing, so we've got A2 and A9. Yeah. I mean, I'm kind of kind of wondering whether I should make factory functions for these things. Could be useful, right? Yeah, it could be useful. Let's do that. So something like so we return an instruction, I guess. Right? Is that what I called it? Where's this thing coming from? Is it in the namespace? Export namespace emulator? No, it's out of the namespace. Okay. That's fine. We just don't need this. I'm getting really annoyed with the position of my delete key in this new keyboard. Yeah, I think that's what we're gonna go for. All we need to do is pass in the emulator registers. Reg here. I think that's it. Right, I think so. In this case, we're just passing the register. Anyway, that should make our lives a little bit simpler now, because we can just do something like 0x a0, and we have make. Ooh. What do I call it? Make LD immediate. And then in here we can pass in the emulator. That's it, right? And also we can have the same thing for the other ones, LDX and LDA. Same shit. So A2 is LDX, right? A2 is LDX, A2 LDX. A2, and then we have LDX, and was it 5? I can't remember now. A9 is A. And we've covered all of these cases here now. LD media, everything's fine as it should be. Do we have a lot of functions? See, we haven't really implemented many of these, but so C0, this is what we want here. Don't like this song, I'm gonna skip it. What? The C0 compare immediate regular. Oh. See, we have another one. We have another one of those. What is it called? CMP. Why isn't IntelliSense not working? Jesus Christ, every time I really need it. Okay, so this is the definition. So again, we're going to have to make a function here. So this is comparing the immediate registry. So this compares whatever's in that register to the value you give by the program, and it just takes one byte, right? compares whichever. Okay. And now we have a compare 0 page. Ooh, this is going to be very interesting actually. So C0, again we're going to need a function here called make compare media. Uintate T program. Oh, maybe I'm thinking very hard of like getting the key for the delete key out and replacing it with the num key, the numpad, because God, that is confusing the hell out of me. Hello, let me know if you guys want me to do anything else on the stream, if this is too boring. Anyway, so this should be CMP immediate registry. And we do have to pass in the program here as well, right? To the oh, this is the function. Yeah, we pass in the program as a second argument. And yeah. Hello Gabrax. Welcome to the stream, dude. How's it going? We're doing some C++ today, so it may not be your cup of tea, but you know, do stick around anyway. I do enjoy talking to people while I'm coding. So make immediate registry. So this is the one that we kind of made a new function for, right? Or which one was it? It was Y. Make CMP Y was the one. Okay. So we pass in the registry. Okay, yeah, cool. Could even inline these functions, I don't know. Anyway, point is, this is kind of done now as well. Now we need to do a different one. So compare 0 page, C5. No, where's compare 0 page? Okay, so we kind of have to do another function for this one. I learned from your video, Conan, and I have a question about generators. Are there for Windows except which generators are there for Windows except VS generator? Right, so there are quite a few, I think. So one thing you can do, Gabrax, is actually go to, let me change the microphone a little bit. You can go to the Conan V2 website and look into the docs, because there is a way you can find all these things. I'm just teaching you where it is, basically. I believe it'll be in integrations. Nope, not it. Maybe they've changed this around. This used to be different. This used to be different. It'll be in here somewhere. There you go. So if you look into the cononfile.py and you look at generators, not here, of course. Commands maybe. Configuration files. They used to have documentation on the available ones, by the way. I'm just trying to find it, so bear with me for a second. There you go, generators here. So yeah, this is not the place. Maybe we just have to use Google. Conan v2. CMake generators, these are the ones available to you. Yes, VS Code Visual Studio is one of them, if you install Visual Studio here. But on Windows, you can also use Ninja, which is the one I actually prefer anyway. So you have to install Ninja on your Windows machine and use this one here. It works with MSVC. It works very well with MSVC actually. And as far as I know, those are the two that kind of work with Windows well. But yeah. Now you've kind of made me realize that I want to know what the Conan v2 generators are, to be honest. Because they used to document it somewhere. Conan v2 generators and Conan tools. Dude, like, where is all the list? Oh gosh, available since this. Oh, I meant the CMake preset. Sorry, I did not specify it. Oh, that's alright. CMake presets are a little bit different though to the generators. So the presets, you can write them yourself, by the way. Yeah, I mean, it just defines how your program is going to be built, like which configurations you're putting into a particular build. So yeah, where to find the Conan toolchain file and where to find third-party modules and stuff. This is kind of what you define in the CMake presets. There is a nice video that I've also released, by the way. I think you might be able to find it if you just Google for CMake presets. There you go. It's a very old video now. It's like over a year ago. Look at me. I had a baby face here, but this video is quite good. For Ninja and others, I get the same error. In fact, I cannot now find. Yeah, I mean, you just gotta make sure that it's installed in your machine, and you can call it from the command line, and it should work fine though. Gosh, I don't want to look at myself again from a year ago. That was painful. Anyway, back to this. What did I do? So compare zero page registry. I just passed in the registry here, I believe. There is a typo. Now what does this take? This takes the CPU in the program. Oh no, it doesn't. Compare, 0 page. There you go. So this takes the program, CPU, and the registers. So program, CPU, program, register, right? That's fine. So the CPU, program, and the register itself. So reg here. And do I actually return the proper thing? No, I don't. Yeah, this keyboard is killing me. Return stud dot okay. So we've got make comp 0 page. I can see this project is very low level C++. I wouldn't say low, but definitely not the highest level. We're not doing anything too low level here. It's just reading bytes from the program. So in terms of low level, just bit manipulation, that's all we're doing here. But yeah, nothing aside from that. This is an emulator, by the way, and you can find the source code. I'll post it here on the description for you guys. Ooh. Oh my god, this keyboard is driving me nuts now. So I think it's 65k CPP. I will try and post this on the link in the description now. Just give me a sec. So that's if you're interested in looking at the source code, you know, it will be there now. So, and this is the chat. Looking at the source code, you know, oh yeah, if you guys haven't done it, yeah, make sure you like the video, by the way. It does help me out quite massively, so I appreciate that like. Socials, links. There you go. The link is in the description now, so feel free to check it out. If you want to help out with the project, I appreciate new commits. And I also will review your code if you fancy helping out. Going back to what we're doing. So we've got C0, so this is C5, right? C5 is the one we want. What actually is C5? It's register A. For what purpose is this emulator? Just for self-learning. I mean, I want to be able to emulate 6502 programs. And truth is, I've been thinking about writing a Nintendo emulator, right? So this is a very good place to start, emulating the CPU. And then the rest you can kind of just go around the CPU as well. So it's for a bigger project, but for now it's just for self-learning and doing some coding on the stream. So registers A, C5. That's what we have here. So we're just turning this whole big ass kind of switch case into a map call, basically, because most of the lines are the same. We add the overhead of the map, but we also reduce the overhead of the readability. Makes things a little bit easier to read. So CA is increment Y, so increment registry. This is the one we want. Make increment registry, and this is the Y. oh no, what we want to do here is pass in the emulator. So registers. Make increment registry, yeah, that's the one. Emulator and the reg. Right. And which one was that? That was C8, right? Incrementing Y. Wait, what the hell is going on here? Yeah, there's a missing. Better now. C8, is that the one? Yeah, C8 is increment Y. Now we have other functions as well. I'm sure that they will be all here. Increment Y is kind of done. Now we've got decrement X. Funny thing with emulators for PS1 is you have to somehow link the original Sony license, because without it the game won't run. Yeah, you're talking about the BIOS, right? So yeah, I mean, you do have to have the BIOS there, and that's kind of the code that initializes the machine for you to be able to run a game. So yeah, it gets it in the right state basically, so you can kind of read game code. And yes, absolutely, you'd need to have either a BIOS that you ripped off your system, or someone who's kind of reverse engineered it. They also create BIOS for it. So yeah. So make decrement registry, right? So that's what we want. So we have that. So increment registry. This should have been std uint8. Oh. SD make optional. And we return 1 now. Actually, I'm just going to change all of these already. Now this function can we inline this? I mean, if you look at it, this function is not really doing anything, it's just one line of code, right? So we can definitely just inline it. So inline in the code. What else do we have here? Yeah, I mean, for now, that was the bit of refactoring that we did. So CA, that's the one. So decrement X. So the way we do this is by calling decrement registry, which decrements a registry. And obviously we're going to have that factory function just so we can make it nicer in the map here that we've got. So yeah. Let's do it here. One thing I haven't tried to do is, like, I've not tried to compile this whole thing yet. Maybe we'll do that after this bit of refactoring. But what am I doing? So return something that takes an emulator CPU, emulator, and something that takes a spam of const stud uint8 t, which is the program, right? And then we're going to return the decrement register of, no, This is going to be funny. Decrement register takes in a CPU, it takes in the emulator itself, and the registry. Yeah. I don't remember if license is necessary for emulating on PC, but when you want to run it on legit on PS1, it won't run without a license. No, I don't, not anymore, dude. Not for the PS1. I mean, I do a lot of emulation. Obviously, I do own most of the games that I have, just, you know, before I get taken down by the YouTube mafia. But yeah, I mean, you haven't needed to have a license for ages to be able to emulate something. You know, people say that as long as you have the game, you should be able to emulate it without running into, you know, piracy issues. Because obviously you can just, yeah, you can kind of download games from the internet and run them, right? You know, everyone knows that. But what I'm saying is that no one will come knocking at your door and arrest you, unless, you know, if you have the copy of your software you're emulating, right? So make sure you do that. So make decrement, and this is the one we're gonna do now. So 0xCA. 0xCA is decrement x. 0xCA, right. Wait, what? C8 and C5 are the same. Wait, well, I've got two C8s. Why do I have two C8s? C8 was increment Y. Okay, so CA is decrement X. That's what I'm getting wrong here. That's better, isn't it? And I had a peak, and I know that the next one will also be... No, not a decrement. Interesting. So we've got branch not equals to. So this is where we change the program counter. So, right. BNE is the one. And in fact, this function does what it says it does anyway. So, in this particular case, we can just pass the function itself. Now, all I need is the code, which is D0. D0 is BNE. No, CPU immediate registry. Compare immediate, right? So make compare immediate, that's the one. So E0 is the one. Make compare immediate, we do have that already. Make compare immediate, so I'm gonna guess it's what, X E0, is that right? E0 X, yeah. So this is increment 0 page and increment register. So E8 is the next one we're gonna do, which is increment register X E8. Beautiful. So we've done this one here. Does feel like I'm gonna get a copyright strike, so I'm gonna skip that song so I don't get messed up too much. Actually, one thing I haven't yet checked is whether or not I've enabled monetization on this video, because it should be. It should really be on. Okay, yeah, you might get an advert or two now, so please don't skip it. It does help me out get paid. So E6 is the one that I need to do. So E6 will probably go here. What was it again? So E6 was increment 0 page. Increment 0 page. I mean, this kind of already does what I want, but like, what does it actually do? Which register does it do? Increment 0 page. Increment register. I'm confused now. So what is increment 0 page doing? So does it literally just like take the position and increment it somewhere in memory? That's interesting. Yeah, that's exactly what it does. Yeah, exactly what it does. All right. Anyway, we have that one problem. Right, so increment 0 page is the one. And I feel like that's everything, right? Thing is, this is definitely not going to compile now. I'm going to try it, and then it will tell me you messed it up. So, let's see. Clean rebuild. If it compiles the first time, I'll be surprised, but many errors out there. So the first one is here. So yeah, I mean, we missed. This is the joys of not having a real-time IntelliSense working with C++, and that's because you do modules. So make optional storage size T. This is fine now, I think. All right, good. That's better. Oh, spawn is not a type. So make optioner. Make optional. Now all of these types have something here. Unknown type instruction. How is it unknown? I have it right here. Unknown name use. What? Oh, using. That is why. What am I doing? Expected unqualified. Emulator. Registers. There's something wrong here. What am I doing? Ah, yes. So. Forgot to actually give it a type, you know. Now all of the typos that I made will be thrown back at me. So no viable conversion returned from value lambda to function instruction, aka function that takes an optional, returns an optional unsigned long. Yeah, that's quite right. Unsigned long. Let's see why this can't be converted to a function object. No known conversion from lambda to no pointer for first argument. No known conversion. Wait, what? I don't understand. Kind of the construction of viable. No known conversion from lambda at 244 to no pointer, because it returns an instruction. Can I? I'm pretty sure that I can do this in C++, right? I can definitely return lambda as function C++. So that's what I kind of wanted. Yeah, so int returns an integer. You don't need a handicraft function object, just use, yeah, this is kind of what I'm trying to do. This is what I'm trying to do indeed. So what is the, what's the problem here? Reg declared here. Variable reg cannot be implicitly captured in a lambda with no context capture specified. That's probably why. Does this work? And if it does, is it right? Because I'm not entirely sure. Now, should I capture? No, this is the question in C++ that I wish I didn't have to ask myself. When you're doing C++ and you come down to something like this, first of all, you ask yourself if you're doing it right, because it's really complicated to kind of figure out here. And secondly, if you are wanting to do something like this, what is the best way that you can implement something similar to this without having to use this feature? And the feature here in question is taking a reference to a structure field, right? So the reference to a structure itself, so that you can kind of, whatever object of type registers you pass into here, you can kind of set a particular value depending on this here. Now I think because this is a reference to the kind of like structured table of registry, we can take it by a reference and not a copy. In fact, I don't really understand what it means for us to take a copy, capture a copy of this instead, but let's go for the reference here. Emulator. Okay, so what's the issue? So that one worked fine. No viable conversion returned from this to this. It takes 3 objects. Oh yeah, that's why. So we have emulator, program, and registry. Now it should be a little bit better. Okay, yeah, better. So again, it takes a CPU and a registry. CPU and a registry. We just maybe gotta do this. Oh my god. Build. Okay, so uint8 emulator C++ no name type uint8. Yeah, there isn't. But that one does exist. No viable conversion from return value lambda. That's probably because we're not setting something here. What does that return? That returns an optional size t. So what's the issue here? AKA no pointer for the first argument. So emulator CPU. Yes, I am confused here. Like I legit don't know what this error means. So the second one says candidate construction not viable, no known conversion from lambda at this to const function optional of unsigned long. Huh. Ah yes. I'm glad that the C++ error actually says exactly what it means, which is, you know, I had an extra comma there, and it told me so, didn't it? So again, here, this is all we have to do. Now, this is going to be the big thing, because this is probably not going to compile either, right? Ooh. What is the issue here, though? Yeah. No semicolon, that's fine. Now, what do we have here? So, non-void function does not return a value in all control paths. First of all, what is this error? Too few template arguments for this? Is that? Is that really? Oh, I'm using frozen. Okay, I'm using the frozen maps. And frozen is, if I'm not mistaken, a compile time map in C++. So let's see how to use it. It's a header-only compile time const expr unordered map implementation, basically, which essentially just means you know, in the source code you're going to end up with a switch case. Anyway, that's what I can tell here. But it makes the code a little bit more readable by us being able to kind of put everything into a map instead, right? Now, frozen set. Let's see. Unordered map. Ah, so we have the size as well. We have the size, right? Registers here, and this shouldn't compile because it's going to say that we have too many. Const expr variable cannot have non-literal type, aka const unordered map. Wait, what? Now let's decipher this. Let's decipher this because it's very interesting. First of all, are lambdas const expr? Are lambdas const expr in C++? And if they are, is std function const expr? Because I'm not too sure now. Oh no, they are not. They are not const expr. That is a shame, guys. That means we can't use frozen. Yeah, we cannot use that. That is a shame. I had hopes that this would be const expr. That's not just an out-of-date documentation page, is it? What is that? Const expr stood function in 40 lines of code. I like that. I very much like this. So, this looks like template hell though. I'm not even going to attempt to read it. But what are they doing here? So they've got a class called function. They've got the operator, this, which basically just calls the function pointer that's stored inside the object. And it contains a unique pointer to an interface. Now, what is the interface, you may ask? Good question, I don't know. Where is it? Function, there you go, struct interface. So, const expr virtual auto operator, this which takes a variadic argument list. And then it had a destructor as well. And we've got the implementation to the interface, which simply initializes the fn to whatever function pointer you pass into it. And fn in this case is, what is it? It can be any type. Great. That's cool. Would I use this now? Probably not. Too difficult to read. So, let's change it to a stud. Another map for now, shall we? We can use frozen later, when we actually turn all of this into a proper project. So for now, I'm just gonna go into here and include my unordered map. There you go. Now this should work, right? No, it should not. Okay, yeah, we just don't return anything in this case. That's fine. What is it called? Now, do we have something like the command? There you go. So the command should really be in here. I'm hitting the shift today. The shift key is definitely not doing me any good. So const exp variable cannot have, okay, yeah, we don't want to make that const exp anymore. Not for now anyway. But definitely a constant though. Okay, so no matching constructor for initialization of const unordered map. This and all of that. Is it because I need an extra one here? I think it is. I think you will like this. Beautiful. No matching constructor for... No, it just didn't like that. Wait, how do you even... I swear that you should be able to do this in C++, like... C++ inline map initialization. There you go, so that should work. Initialize lists there, that's what I'm trying to do. Requires almost 16 arguments, but what? Different ways to initialize an unordered map in C++, yeah. We don't want that. We don't want that. Use braces instead of the parentheses. Like, dude, I have. I definitely have. So are we missing something here? So stood. Is it even possible to initialize an unordered map in C++ with initializer lists? I don't actually know. Usually it's... I work with maps most of the time, to be honest, but... Yeah, there you go. This should work fine. Don't understand what I have here. That's sexy looking keyboard, nice. Thank you, Al. You haven't even seen what it sounds like, dude. But this should work. I don't understand why this is not working here, to be honest. Now let's go down a little bit. Like, what in the hell is going on here? Unsigned car to function. Instructions. Cannot convert initializer list to argument size type, i.e. unsigned long. But why is it trying to do that? That's convincing. I really might order one myself. Yeah, dude, it's really good. I mean, I've been enjoying it. Like, I'm missing keys because I'm not used to it, yeah. But once it's all done, then once I'm like over my older keyboard and I can type faster on this one, yeah, it feels a lot better. Like, typing feels amazing on this one. Not sure if you can see. This is what it kind of sounds like. Let's open Godbolt or something. I'm gonna type in a Hello World program so you can kind of see what it sounds like. Oh. And that's it. What keyboard did you have previously? I had a very old, sort of like Fanatic keyboard. It's the Fanatic one, the gaming brand. Are they even still around? But yeah. So I bought a keyboard by Fanatic, this one here actually, which was pretty good, to be honest. It did last for like maybe 5 years. It's still working just fine. But it just doesn't have the sort of like touch feel that I want to a keyboard. But yeah, that's the one I had before. So, something is wrong here. So what is... Cannot convert the initializer list argument size t. I don't understand what is going on. This should be working fine. Instruction. Now this one here compile. Yeah, so it's something to do with these guys over here. Ah, okay, so what do we have here? Sad thing with these keyboards is they come with loop switches, and when this loop grinds off, writing gets louder. Oh right, I shall buy myself some switch loop then. How long does that take, Gabrax? Do you know? Is it like a year thing? Like after a year you're gonna have to lube it, or? But I'm loving it right now. Like the feel to this keyboard is just so nice and creamy. It's amazing. So let's comment all of these out. Let's try and isolate the problem. Compile it. So that worked. So it's not this here. Then it's making me think that's probably this value, right? Yeah. So TXA is actually the problem. And you can tell why, right? You can tell why exactly. It's because this function isn't the same as the other functions. Like this function here takes two parameters, which is the CPU and the spam value, so the program. So yeah, and TXA doesn't do that. So yeah, that's the problem. With my keyboard, it got louder after a few months, but it's still kind of creamy. Okay, cool. Like maybe I should probably look for the loop then, right? At some point, because I kind of just wanna. I want to be able to hear this all the time, though. I don't want it to fade away after a few months. So yeah. This should build now. Perfecto. Yeah. Now let's uncomment a few others, see what happens. This one does take the right thing. Yeah. Let's see what's going on. Hey Matt, how did you install Raylib with Conan under WSL2? I'm getting an error which is quite confusing and I can't seem to find a solution online. Yeah, send me a screenshot, dude. You're lucky that I am very, very good at Conan. I'll help you out with that, don't worry. Usually when I find errors with Conan recipes, I kind of fix them. So you can, if you go back into my GitHub profile, you can see just random fixes on random recipes on Conan. But I know for certain that the WSL2, sorry, the Raylib version of Conan, so the newest Raylib version in Conan, does build in WSL2 fine though. I'm pretty sure, because that's what I did, so. Okay, so this one clearly has a different spam const program. STA absolute. Oh, there you go. It takes the address. Yeah, that's why it doesn't like that. That's why it doesn't like that at all. But you have two functions called STA absolute. What the hell? First of all, I don't need that. Second of all, STA absolute is gonna die now. This is where it should go. Let's remove these functions that only have like a line. Okay, so remove that, remove that. Now, this should work. Ease of undeclared CPU memory address. So the address was something like the high SB. And LSB, right? That's what we have there. Okay. Bit by bit, we're making this all compile. Now I'm sure this one compiles as well. I'm sure that all of these will compile, in fact. Do you reckon if Conan libraries are different than you downloaded from official sources? Do you reckon if Conan libraries are different than downloaded from official sources? Gabrax, they are not usually different. In fact, most of the recipes kind of download, like, they will download the source code from GitHub, from the package you want to build. They will extract the source code into your Conan building folders and simply just call like cmake on that project with some extra configurations. That's what Conan does for you. Now, it doesn't make it impossible for people to maliciously change that source code link. So instead of downloading Qt from the Qt GitHub page, you'll be downloading a shady version of Qt that's kind of laced with some bad like code from, I don't know, like Russian viruses or something like that. It doesn't stop people from doing that, obviously, but it's all open source, and for you to be able to put a recipe through Conan, several people will read it, several people will try to understand it, and it's a bit difficult, but you know, it's not impossible. You know, it's not impossible for people to put whatever bad source code they want. So yeah, I mean, answering your question is not usually different, but it can be. Yeah, it can be different. So right, that build, BNE, does it build? I love Donkey Kong Country, but it's Nintendo, right? So they might call us out. So let's skip it. Right, so the map is here now, which means this is very easy. What does find return? It returns an iterator, right? Iterator, const iterator. I think it's second, you know. Now, what do we do if we don't have if we have an unsupported function? This is what we do currently, right? That's what we do. And this will actually return us the byte thread, right? So the byte thread is what we have there. Okay. Yeah, so we simply return that. And this whole thing here, it just goes. It just goes. It's as beautiful as that, really. That's why we did the whole thing. So yeah, we are gonna comment all of this out. I don't want to get rid of the code because, you know, I'm a noob, so if it didn't work, I'm just gonna uncomment it and see what I messed up. In fact, it becomes even simpler because this should really be. Ooh. Should just be that. Now, are you guys ready to watch all the test break? Because I am. Let's get it. Let's get it. So many failures. It's ridiculous. Wait, what? We got Lincoln failures. Oh no, we got address sanitizer issues as well. That's amazing. Anyway, this is how we do a refactoring. I'm happy you enjoyed the stream. This is how you do the C++ refactoring. You change some code, you make it nice and easy to read, and then you've introduced 100,000 bugs, including very serious memory issues, as you can see here. But yeah. And don't get me wrong, this is a C++, not a novice, I would say. I've been coding in it for a long time, probably the language I did the most in my life, and I still I still make mistakes like these. So you're new to this? Don't worry, mate. Just keep going. I'm trying to find, like, where do I even look in the arrows here? So const registry. Brock Daniel. Sad face. Indeed, man. Indeed, dude. Stack use after return. Stack use after return. Right. There's a stack use after return here. Maybe we copy these instead, right? We copy the references. Let's see if that improves things. I don't think it will though, but we can try. So for those interested, stack use after return, like, is when you kind of reference an object in your function stack, and you kind of return something that still references to that object in the stack, but you've returned from the function, so the object is no longer there, right? Let's see if we can have a little example here. So this is a primary example of how you can cause this. So yeah, you've got a local array here and a pointer that references, and you store into the pointer a reference into your local array, but pointer is global, so you still have, you know, that being used later on, which obviously is an issue. Do I think that was the cause? No, I know that it wasn't. Oh no, he was the cause. There you go. But yeah, we got rid of the address sanitizers. I thought we had another issue with also the references in the CPU here. I thought it was going to tell me off for doing that. But C++ doesn't care if you pass in a reference to the function and still use that after return. I want to work professionally with C++, but memory leaks and linking errors are awful. Yeah, you should. That's how you should think, dude, because they are awful. You know, if someone like myself, I'm not trying to brag or anything, but I've been doing C++ for a long time, maybe over 7 years now, altogether. You know, I still write the silly mistakes all the time. It just kind of shows you how the language can improve in the diagnostics like features, right? So you take any sort of modern language nowadays, so Golang, Rust, they would both kind of tell you at the compilation time that what you're trying to do there maybe isn't correct, and you maybe should think twice when using references to a local object that's being returned by the function. So yeah. But anyway, you know, everyone's gonna make those mistakes, right? We did cause a lot of failures in the tests. So yeah. The very first one is this one. So what is going on here? So the program that we have is A9, which, if I'm not mistaken, what is it? We can, now that this is all easier to read, A9 should be LD immediate. So it loads into registry A, an immediate value, right? And we're not seeing that. So we expect 0A to be stored in A. And we don't have that. So this is definitely doing something fishy, and we can figure it out. And then this just reiterates how important it is for you to actually write a lot of tests for software as soon as you're done with it, or even better, before you're done with it, so you can kind of know what to expect, right? So if you change something elsewhere in the code, and it broke something on the other side of the code that you have no idea of, you have no way of knowing that until you've run all the regression tests to make sure, or at least give you some confidence that you've not broken anything like major. So yeah. And as you can see, whenever I make any change in my code, I always break tests. I'm not really scared of breaking them. It's just part of development, right? You shouldn't be scared of breaking tests. This is something that everyone kind of who's starting off thinks, I believe. So they're scared of changing something because they know it will break like 100,000 tests or something. You know, don't be scared. You're going to do that anyway. It's required for your code. What you should be scared is not being able to understand why you've broken something. So whenever you break something, do take some time to actually go into the test case and kind of read and understand what the person writing that test intended for that test to show you. So that's how I find development useful. Why the hell do we have the program running here forever? Emulator tests. Okay, that's freakish. So we have a corrupt cannot merge previous file. That's weird. What the hell is going on here? I have a corrupt GCDA file. Okay, nothing in there. We can't. I don't know what this is. I need to look into it. This is definitely like another messed up C++ thing we've added to the file somewhere. So there's a corrupt arc tag. I have no idea what that means, but it's to do with coverage. It's not able to merge the coverage files for some reason. Mismatched number of counters. Yeah, not entirely sure on that one. Do you still run all the code on your Raspberry? No, this code is running on my main machine. So only occasionally I turn on the Raspberry Pi and then run the code on it. But it's not all the time. Guys, I'm actually going to call it here. So I'm going to fix this issue later on. This is going to be one of those where it's quite difficult for me to figure out what I've done wrong. Unless I debug through the code, and I don't want to do that for another 30 minutes because I kind of want to go to bed early today. And anyway, I just came here today to kind of show you the the keyboard and do some coding along the side, along that as well. And it was amazing seeing some of you. Gabrax, thank you for joining today, dude. Hopefully we have some more people we can chat to next time as well. But I'm gonna call it here, guys, and I'll see you again in the next few days. Bye bye. Have a good night. Thank you all.